All right, let's get this show on the road. My name's Ashley Grant, and I'm here to talk to you about JavaScript or ECMAScript without any Webpack, Transpilers, or frameworks, although there's a secret little bit of fun at the end where I do use a transpiler, but still no Webpack or frameworks. So let's get started. So the agenda for today, we're going to be looking at my sweet jQuery app from 2012. It's an application that should look familiar in terms of the code base for all of us. It's applications we've written before. It actually doesn't use any framework. It's just a jQuery-based application. We're going to look at that. Then we're going to start learning about ES 2019. We're not going to learn about Webpack. We're not going to learn about transpilers. And we're not going to learn about frameworks. All of the features that we learn about today, though, we will use them natively in the browser. And with that, we will be awesome. So first, let's get to that demo of the jQuery app. So this is my awesome jQuery app. This is its code. You'll see that it has a lot of HTML in here. I am using Bootstrap for CSS because I'm not any good at that. But down at the bottom, you'll see that I load require.js. And this should look familiar to all of us who have been doing web development for a few years. You load require.js, you configure require.js, and then load your application using require.js. Now, if we look at the source code for this application, well, first off, we have the require.js configuration that we are required to write for require.js. I come in here, I set up a base URL for where my application lives and some paths. If I needed to, I could shim in libraries. I don't need that for this application. But in here, in my actual application, when I want to write code, I have to use a module format called AMD, Asynchronous Module Definition Format. So when you write an application using this module format, honestly, I feel like it's finicky and, I don't know, it's just not friendly. It's not user-friendly to me, especially defining module names using strings and things like that. I'm just not a fan of it. The other things that we have in here, I have a lot of jQuery. I'm setting up click event handlers. I'm declaring some variables. And then if we come down into welcome, we'll see some var me equals this. Who's written something akin to this in their life as a JavaScript developer? Yes. So this application holds a lot of ES5 style code in it, but it does work. It runs very well. Here we go, my first jQuery app. I've got data binding set up, so if I want to change my name to Thomas as I type, the data binding handles all of that. This is all done using jQuery and native JavaScript that was available since 2009. I have pages in here, so I can go and load this page that has all of the GitHub users. And it's a pretty simple application. If I click submit here, you'll see that my name comes up. And going back to the source code, I want to show how much jQuery there is in here. We have something called an HTTP client. If we look at that, it's just a wrapper around jQuery. So now that we have this application, let's talk about some of the ways that we can utilize ES 2015 and up to make this application better, but only in ways that run natively in the browser. So yeah, the browser can do what? Let's look at some of the things that today's browsers that are shipping today can do natively. The first thing is getting rid of something called var. In ES5, in every version of JavaScript before ES 2015, when you wanted to declare a variable, you had two options. You just didn't declare it, you just started using it, or you could use the var keyword to declare it. But the problem with this var keyword is it doesn't work like developers expect it to. If you come from a C or a C++, Java, C# background, you're used to variables being declared inside of a set of curly braces, and that variable only lives inside of that set of curly braces. And with var, that only happened if you were inside of a function. If you're inside of an if statement and you declare a variable using var, it's going to be hoisted up to the top of whatever scope it can get, whatever function scope it is in. So it wasn't good. Unfortunately, JavaScript developers had to live with this for 20 years. And there was all kinds of ways we got around this. Basically, they all boiled down to wrap everything in functions. And that's a bit of a pain in the butt when you just want to write an if statement, right? Thankfully, with ES 2015, we got some new stuff. We got let and const. These are keywords that work with and to declare variables using block level scoping, which means that if you have curly braces, if you have a pair of curly braces and you declare a variable inside of them, that variable will not exist outside of those curly braces. Let's look at how this can help solve problems that var has. So here I have a function just called foo. It takes in an input, checks to see if input is greater than 5. If it is, then inside of that if statement, it declares a variable called output, multiplies the input by 2, and then outside the if statement, it returns the value of output. Now, I do want to say that if you run in strict mode with ES5, this will throw an error, okay? But if you're not running in strict mode, what will happen is when you run and you call foo7, you'll get an output of 14, okay? Because you declared output. It was hoisted out of that if statement. The declaration was hoisted out of that if statement to the top of this function, which means that this return output is perfectly valid, okay? But for me, as a recovering C# developer or C++ Java, I look at this and I say, output should be undefined, right? Shouldn't it be undefined at this point in my code? I should get an error thrown of some sort. Well, thankfully, now if you use let or const, you do get an error with this exact same code. Just swapping let in for var or const in for var fixes this problem. Now we get reference error. Output is undefined. Another nice thing in ES 2015 is that you're no longer allowed, if you're writing ES 2015 code, you're automatically in strict mode. So using undeclared variables is not allowed anymore. And so in this first code, the code on the left, I'm running all of this code inside of Chrome's developer tools. And because I did not use any ES 2015 features, Chrome allowed me to be not in strict mode. So it just allowed that to run, and it was happy with it. Over here, though, because I used let, I'm just like that. I'm into strict mode, and I'm not allowed to use undeclared variables. Because with an undeclared variable, technically, that return output might work in JavaScript. Also, we no longer have hoisting. And hoisting is where the var whatever the name of the variable is, actually gets lifted up to the top of your function, whether it's deep inside a bunch of if statements and switch statements and loops and everything, or it's in the second line of your code. The JavaScript engine would just say, whoop, let's send that up to the top. And so code like this was perfectly valid. Because when this code runs, what the JavaScript engine will do is take var a, move that up to the top. It'll say var a, but it will not initialize the value like I'm doing here where I say var a equals 5. It'll just put var a up there so that that code, or that variable has been named. And then it'll run a equals 7, so a becomes 7. Then it'll run a equals 5, so a becomes 5. And thus, 5 gets logged out. Personally, though, as, again, C# Java-style developer, I look at this and I say, that code is wrong. I'm using a variable before I declare it. Why is that not throwing an error? Well, thankfully, in ES 2015, again, A is not defined. When I say A equals 7, I haven't declared A yet. So by using let and const, we get rid of these types of errors. And these can be really pernicious. You know, because that using var, it gets hoisted up to the top of your code. Maybe you're using the same variable in same variable name in two different places, but in like in the second place, you do something if it hasn't been explicitly set, but somehow it's explicitly getting set. And you're like, what is going on? No longer have that problem with let or const. Now, let and const. Let declares a variable that's value can change. Const declares a variable that is constant, which I realize is a contradiction in terms, but that's how it is. Now, when you declare a variable using const and you set that variable equal to an object, for example, you can still change properties on that object. The properties of the object are not constant. It's just the value of your variable, which in that case would be a reference to that object, that cannot change. When I'm writing JavaScript code, I default to const and I fall back to let. And I never, ever, ever use var, period. I have ESLint or TSLint rules that will flag that as an error so that it can never get into my code. Next, classes. We always had a problem in JavaScript where building classes was difficult because JavaScript is a prototypical language. It uses prototype inheritance, and I don't know what that means as a C# or Java whatever developer. It meant that declaring classes was really wonky, and so with ES 2015, they decided to give us the class keyword. Under the covers, this is just syntactic sugar. Your code actually, as far as the browser is concerned, gets transformed into the old way of declaring classes. But the best part is it's always transformed correctly. And I'll tell you what, the code you're looking at on here, at least once when I've given this talk, somebody's told me I did it incorrectly. And that was a problem with declaring classes in ES5, was I'm not sure if this is correct. You know? Now, a lot of us use something like Babel or TypeScript to transpile classes into this syntax. But here's the thing. That's not necessary. The browsers natively understand. All of today's browsers natively understand what a class is. Remember, every single piece of code that you're seeing on here, I ran in Chrome. And here's the thing, I didn't run this in Chrome yesterday. I ran this code in October. So this isn't new. This stuff's been around for a while. I actually did a version of this talk in 2017, and the browsers still, including Edge, understood the class syntax back then. But so here we see I have moved from the old syntax to the new. I personally feel like the new syntax is a lot friendlier. Does everybody agree? Yeah. Now, if you're a functional developer and you think that the class syntax or the class keyword is the worst thing to ever happen to JavaScript, that's cool. That's fine. Nobody's forcing you to use it. Don't use it. I prefer this syntax because I think in classes, so I'm going to declare a class. And as you see, though, the old school way of doing it, which apparently might be wrong, works exactly the same as the new school way of doing it. Now, this is not ES 2015, but every conference you go to, you're going to have somebody standing on a stage telling you should never use jQuery ever again. I get it. jQuery is still useful, even in 2019, but it's not useful for the reason most people think it is useful. Most people think of jQuery for, personally, I think of two things. Widgets, all those beautiful jQuery UI widgets, or dealing with the DOM, because DOM is unfriendly. And for widgets, yeah, it's still very useful. I will say that through the use of modern frameworks and everything, or just modern code, it's a lot of times not necessary. Like there are vanilla JS or framework-specific versions of those widgets that are better to use. They don't use jQuery. But for just working with the DOM, there is no need to use jQuery. The DOM natively has the APIs for you. So this is a simple decision tree for everybody in here to remember in terms of whether or not you need jQuery. I would say in here, if you're using a current version of Bootstrap, you got to use jQuery. But that's going away as well. Bootstrap's getting rid of its need for jQuery. This code right here, there's no need to use jQuery. Use document.querySelectorAll. This has been in the browsers since IE 8, I think. This is not new. This is available. And if you don't like having to type out document.querySelectorAll and you really prefer using a $, just say let $ equal document.querySelectorAll. You're golden. Now, for those of you in the back, this might be a little bit difficult to read, but here I have some jQuery code for setting up a click handler for links on a page. And then here I have the DOM native API for how to do this. Now, I will say that I personally think that the jQuery API for doing events is a lot friendlier than the DOM native API, but when you look at how big jQuery is in terms of download size versus just writing out a little bit extra here, I feel like it becomes harder and harder to justify the friendlier syntax there. So jQuery, not even once. Arrow functions. Arrow functions are awesome because they solve another fundamental problem with the JavaScript language, which is that the this keyword can be whatever a developer wants it to be. There are ways to call functions where you set what this is going to be. And if you have written your function expecting this to be one thing and the person who calls your function sets it to be something else, your function's going to fall apart. I bet this has happened to you before. And thankfully, with arrow functions, this problem goes away. What arrow functions do is they take whatever this is in the lexical scope that you write that function in. So wherever you write this arrow function, whatever this is at that point that that code runs, it takes this and makes sure that it stays as this inside of your arrow function, okay? The other thing that they do is keep you from having to write the word function repeatedly. So that's nice. Let's look at some problems with the classic style of writing a function and how this can be hard to figure out. So I realize this is difficult to see, but it's a function that says, hey, what's this? Here, I'll make it a little... Can everybody see this? Yeah? Okay. So, hey, what's this? It'll log out this at the beginning of the function. It has an inner function called are you sure? It logs out, again, what this is and calls that function. So, if I just call from the console, hey, what's this? What do you expect to be logged out first and second? In the global scope, what is this going to be set to? At least if you're running in the browser, it's going to be set to the window object, okay? So when I just, from the console, I call, hey, what's this? I would expect that this inside of my function is going to be the window object. But then what about inside of that child function? Is it still going to be the window object? Or is it going to be like that function, the hey, what's this function? This is stuff that's hard to know inside of old school functions. So here we see that in this case, it's always window, right? But what if I use the .call function that's available on any function to set what this is going to be? What do you expect this to be on the first line now? This is audience participation, and it's fine if you're wrong. In fact, I hope you're wrong. So when I call hey, what's this? And passing in or using .call, that means that I'm setting this inside of that function to be whatever I put here. So in this case, it's a string. So I personally would expect that on the first line, the first console log, I would expect to see the string it me, okay? But then inside of that child function, what is this going to be? Is it going to be it me, or is it going to be the global this? What do you think it's going to be? You're not sure? As a naive JavaScript developer, I would, given that I've just run it using the global this and they were the same, I might expect that they're going to be the same. But they're not. When I call into are you sure, now this is still the global window object, but this outside of that was not. And this is the type of code that will trip you up, because I bet you most of the time when you write code like this, when you have a little child function, you're expecting this to be the same thing as it is inside the outer function. Well, thankfully with arrow functions, now we get that, okay? So here, the only thing I've changed is instead of declaring are you sure with the function keyword, I'm using an arrow function. And now when I call it globally, it works exactly the same. But when I use .call to set what this is going to be when I call, hey, what's this? This stays the same for both of them. I think that this is, syntactic sugar that is super sweet, because I'm able. Now I could have done this in the old way. I could have used, when I said are you sure inside of hey, what's this? I could have said are you sure .call this, and I could have made sure it was the same. But who's going to remember to do that? I use arrow functions all the time. One place that I use arrow functions doesn't even have to do with this most of the time. It's just because it's a more terse syntax, but is using promises. Now, one thing with promises is we have this new thing called fetch, which is a native API for making HTTP calls. Now, in jQuery, or in a lot of old school wrappers around the XML HTTP request API, you would use callbacks, and you would end up getting into something called callback hell. So, my slides are out of order. But now, instead of using callbacks here, like $getJSON, and then I pass in a function, okay? And what's the problem with that? I don't know what this is going to be when I write that. Now I can use promises, and I just say fetch a URL, and then parse out the JSON, and then log it out. And the cool thing is, because I'm using arrow functions here, if I were inside of a function, maybe inside of an instance of a class, and I want to take the data that I pulled down from that API, I can say this dot my data equals data, and it will automatically work the way I expect it to. But where promises and fetch really shine is when you might be making multiple dependent API calls. I realize this doesn't happen too often. This is often a sign of an overly chatty API. But let me ask you this. If I want to use some of the data how do I do this where I want to use some of this data somewhere else in my code? I got to write callbacks and call I don't know. The promise-based API is so much friendlier. Here, I just say, .then, parse the JSON, go fetch the URI that I just got from that downloaded data. Do it again. All right, now I'm going to log out the data. The other cool thing is that I don't have to worry about having a widescreen monitor and like a 4K widescreen monitor because everything's going off the side of the screen. With fetch, everything stays in one line. Or sorry, with promises, everything stays in one line. Not sure why my arrows are out of order. Here's one, though, that is probably going to blow all of your minds, which are modules. Native ES 2015 modules work in the browser. Here we go. I've got some module called main.js that I loaded up. How did I load it? Well, instead of saying script type equals JavaScript or whatever, I say script type equals module, and that tells the browser, go ahead and run this code using your module loader. And all of the modern browsers support this out of the box. And so as you see here, it loads it up, and I'm using import statements inside of main.js, and the browser knows how to parse those as well, natively. There is one difference when you're using native modules compared to if you've gotten used to using ES 2015 style modules, but with a transpiler, okay? You'll see here that with my import statements, I'm including the .js. That is currently required when using native modules natively in the browser. You have to include the extension. When you're using modules in an environment that gets transpiled, typically you don't have to include the extension if it is .js. That's just assumed. So that is a little bit of a wrinkle for you to remember. But we'll look in a minute at how that might not be a wrinkle. Next up, we have for loops. In JavaScript, we have had a for in loop for quite a while. The problem with the for in loop is that it doesn't do what you would expect if you're used to a for each loop, for example, in C#. They don't loop over what you're expecting. Thankfully, with ES 2015, we now have a for of loop that does loop over what you're expecting. Now, when I say the for in loop does not loop over what you're expecting, what do I mean? Well, here I have an array that just has two words in it, hello and goodbye. And I use a for in loop to loop over the items in that array. What do you expect I will see when I run this code? Obviously, I'm going to see the word item show up twice, but what will be after that? Any guesses? Personally, coming from C# with a for each loop, I would expect to see item hello, item goodbye, right? That's not what happens. When you run this, you get item 0, item 1. Because what a for in loop does is iterate over the properties, basically, of an object and indexed property, and the indexes of that object. And that's not what I expect to do. This is workable. I can use this, but if I'm using this, it's almost like, why not just use a for loop, like an old C-style for loop? Thankfully, the for of loop works the way I would expect it to. So when I say for let item of array, I get hello and goodbye as I would have expected. Personally, I would consider maybe setting up a TS-lint or something, because it's very seldom that you're going to actually want to use the for in loop unless you're in like a framework, like you're writing a framework. Typically, when you want to iterate over an array-like object, you're going to want to use the for of. The other cool thing with the for of is that it actually works with something called iterables. And so you could conceivably have a for of loop that goes on forever if you, and I'm not going to get into that, but look it up. Look at iterables in ES 2015, and it's a really cool feature. Next, string templates, or template literals. These are syntactic sugar, plain and simple, but they're available to us now in the browser. Instead of wrapping your string in either single or double quotes, use a backtick like that, and wherever you want to template in values, write an expression inside of a $ curly brace. Now here's the cool thing. You can write expressions inside of the $ curly brace, and that's what I just said, right? And then I said it's the cool thing. It's the cool thing because that means you can write arbitrary JavaScript code inside of there. Now, I'm not saying you should, but conceivably you can do just about whatever you want inside of those curly braces. But the cool thing I think of on a daily basis is the syntactic sugar of shortening up things like this. Hello, name.first, name.last, that's my name, I'm being greeted. Now I just say hello, $ curly brace, name.first, space, $ curly brace, name.last. It's a lot terser, and I think it's also a lot more readable than using string concatenation. You can also use it And actually here is a spot where I'm going to show you how you can write arbitrary code inside of there. So I have this add and log that here, using the old school string concatenation way of doing things, I wanted to add up these two numbers, or the two values that are passed in, and then I wanted to write it out. But because string concatenation uses the plus sign, I can't add those two numbers. Now maybe I could put them in parentheses or something, but that's wonky. But I can get rid of a line of code now by using string template literals by interpolating in the x plus y. And it actually adds those two numbers for me in line in this code. Now, a minute ago, I talked about promises using fetch. But here's the cool thing. If you don't like writing .then continuously, if you look at that syntax and you're like, that's so 2015. Well, we don't have to do that anymore. Natively in the browsers, we have async and await. Now, the cool thing with async and await is that they're built on top of promises and generators, and that means that you can await a promise. You can also do some stuff with generators, but most people don't end up writing generators, but we all end up writing promises. And so that means that instead of saying fetch, going out to the GitHub API to get the users, converting it from JSON, or parsing out the JSON, and then logging out the 0th person's login, we can await that response. And then I'm using something here I haven't talked about, but this is, I'm reaching into the first item in that array and grabbing the login property out of it. And this is more syntactic sugar that JavaScript gives us nowadays. And then I just log that login variable out that I declared. And I'm awaiting both of these. Now, I do want to talk about the await keyword specifically in the console. When you're writing code using async and await normal code, you have to put anytime you use the await keyword, it has to be inside of a function that's been marked with the async keyword. So async function, blah, 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 and then you can await stuff inside of there. That's a bit of a pain in the butt when you're just wanting to do some quick code on the console. Unfortunately, when Chrome first started supporting async and await natively, you had to still do that on the console. And that was really annoying. But recently, last summer, I think, they stopped requiring that. And now you can await things at the root in the console. And that's really awesome for someone like me writing out these demo pieces of code and running them. Again, every piece of code you see in this slide deck is running natively in Chrome, okay? So the browsers support this stuff today. Edge supports this. Safari, Firefox, they all support these things natively. And the new version of Edge is built on top of Chromium, which basically means that anything Chrome supports, the new Edge supports as well. Now, you could start getting crazy with using all of this and use the thing I was talking about a minute ago is called object destructuring or array destructuring. And so here, when I reached into this array and grabbed from the first item the login property, when I reach into the array, I'm using array destructuring, okay? And then when I reached into that object inside the array, I'm using object destructuring. It just allows you to pull properties or items out of arrays and immediately declare them as variables in your function. And so I'm using that here in this crazy code where I have a wrapped fetch, and I'm just assuming I'm always going to get JSON back. So I have an async function called getJSON. I await the fetch, and then I return await result.json. Actually, the await is not necessary there, but I haven't updated the slide. Then I call that function using this promise.all helper function. Promise.all is a native library function in promises that says, I need you to create a promise that will not resolve until all of these promises I'm passing to you have all resolved. And then I want you to pass me the result of all of those functions as an array of promise results. So I await all of those functions in one line, And because I'm awaiting promise.all, all of the outputs of those functions, they're no longer promises. It's stripped off the promise and just giving me the data. And so I'm reaching in. I have 2 items in my array. The first one is a list of users. The second one is a list of events from GitHub. And so on this first line here, so on this line right here, what I'm saying is I want to reach in. I'm throwing away the first item in the array. That underscore, that's not special JavaScript syntax. It's just kind of a pattern for saying I'm ignoring this item. So I'm ignoring the first item in that array. I'm going to the second item in the array, which is an object, and I'm reaching in and grabbing its login property and declaring that as a local variable inside my function. On the second line, the next line, I'm reaching in, this line right here, I'm reaching in to the first item in the array, which has a repo property. Every event that happens in GitHub happens on an event, happens on a repo. So I'm reaching into that repo property, and I'm destructuring that repo property, which is an object itself, and it has a name property. So I'm grabbing that name property, but for my purposes, I want to give that a different variable name. So I'm changing the name of the name property to be repo name when it becomes a variable. And then I'm able to log out second login and event repo. And the time I ran this code, that's what I got. Every time I run this code, I'll get different results because the events stream is always happening. Next, let's talk about the REST operator. Here I'm using the REST operator with arrays. And what is the REST operator? It's this ... here. And it basically, it's just like the slide title says. It says, give me the rest. So I have an array of languages, JavaScript, HTML, SQL, C#. Now I'm going to reach into that array using destructuring, and the first item in that array is going to be now a variable in my scope called languages, or language for this talk. And then I want to take the rest of the items in that array, that's where the name comes from, the rest of the items in that array, and put them into a new array called other languages. So that's the REST object there. And we'll look at, hopefully in a minute, we'll look at some things you can do with that. Now, this is the array REST operator. It works exactly the same with objects, though. You can have object REST and object spread. We'll look at spread in a second. So here I have an object called car, and it has a couple of properties, manufacturer, all of that stuff. And I want to reach into that and pull out the properties that are special for an electric car, and then put everything else into an object called normal car stuff. So I'm using, again, object destructuring and then the REST operator with the object. So now I have a range variable, battery capacity variable, and then everything else inside of the normal car stuff object. I use this all the time. Both of the REST operator, object destructuring. I write code that looks like this all the time, and when I switch back over to writing C# code, I miss it dearly. So that was the REST object, the REST operator. But there is another operator that looks exactly the same that's called the spread operator. And it kind of works in the opposite of the REST operator, where the REST is taking the rest of things and grabbing it up. Now, with the spread operator, I'm taking everything and spreading it out. It's like peanut butter. I'm spreading this object out like peanut butter, or spreading this array out like peanut butter. So here, I've got my car object that I just had on the last slide. But now I want to give my car a name. It's a Tesla. All Teslas have names. So I say my car name Timmy, and then ... car spreads all the properties from that car object into the my car object. And Timmy is actually the name of my wife's car. So, also here I'm using console.table. Maybe you haven't heard of that. It's a nice way to represent an array or an object in the console. So what is a useful thing to do with this spread operator? Well, it's a great way to make copies of arrays or objects. You may have heard of, object.assign is a new ES 2015 library feature or library function that allows you to take all the properties from one object and assign them to another object. I find that using the spread operator in an object is a much terser and friendlier syntax for doing that, and it works the same here. This is a really old SNL skit that Rob Schneider did, Making Cappies. It's probably way before you guys' time. But anyways, so here I make a copy of that names array, and we see that first off, they're different arrays. I'm using the strict equality operator there, so they're not the same array, but they have the same properties or the same values. Now, I have spent 40 minutes talking about features that run natively in the browsers of today, right? But what about IE, right? I'm showing you how to natively load modules using this type equals module. But we all know that IE has not received any updates in I don't even know how long. And you know that's a problem because, well, IE doesn't know about promises, IE doesn't know about async await, IE doesn't know about templated literals, the spread operators, the rest, it doesn't know about any of that. So can we have a tip for the poor souls that are stuck supporting them? Here's the cool thing. Type no module on your script tags, or not type equals no module, just no module. That's a typo. No module comes to the rescue. So when you have a script type equals module, browsers that understand that will load it, okay? But Internet Explorer has no idea what script type equals module means. So it's not going to go and load and try to run the JavaScript in script/app/main. So that's great for us because it would error out if it tried to run that. This no module attribute has been added and allows us to say to browsers that support modules, don't run this. But Internet Explorer has no idea what no module means, so it ignores it and it says, script source, I know what that means, I can load that JavaScript. And so here, I'm using native modules if the browser supports it. Otherwise, I'm using require.js and I have a legacy setup. And we're going to look at a demo of how to use this in just a minute. But first, we're going to look at a demo where I did all of this by hand, which is my ES 2018 application, the version of our jQuery application that we looked at a minute ago. So remember, this is my jQuery app. I do stuff in here. Data binding works. I go over here. I see my list of GitHub users. Now I have a modern JavaScript app, and you know it's modern because it says so in the title. It works exactly the same. As I type stuff in, the data binding is working. If I click submit, that works. If I try to change pages, that works. So it works exactly the same, but the underlying code base is all pure ES 2018 code. Let's look at it. So instead of having, main and jQuery and require.js and all of that, now I have a scripts folder. In my lib, I just have this HTTP client that I wrote now to use fetch. And I have main.js where now I'm using import statements. I'm loading up things using const. I think there might be a var that snuck in somewhere in here. And then, so I import the two pages, welcome and users. Let's look at users. In users, my activate now, it's an async function. I just await get JSON, telling it to go to the users API. I use query selector on that ID users container, and I set the enter HTML. And then here, I create an empty string, and then I'm concatenating onto that using the spread operator. I call data.map. Data is an array of GitHub users, and I'm calling .map on that. I pass each item in that array to the this.generateHTML function, which will take this inline template that I've written and spit out the rendered HTML for each individual user. And then I use the spread operator to rip that array apart, and it when you use the concat function on a string, you can pass an n number of items, n number of strings to it. And so I don't care how many items are in the data array. Previously, I probably would have built this using MapReduce, and it would have been a lot jankier of a syntax. I feel like this is a much friendlier syntax for taking an array and concatenating it into a single array, or sorry, a single string. If we come back, or if we go over to welcome.js, I'm now using a class instead of the janky old school style of programming classes in JavaScript. You'll see that instead of using, in my activate function, if we look at, in the jQuery application, if we look at welcome, there's an activate function somewhere, right here. I use that var me equals this, but because I'm using a proper class, this is going to be what I expect it to be. And then also, because I'm using arrow functions for my event handlers, this will be what I expect it to be inside of those as well. And so when we go back and look at that code, we see a much smaller amount of code being written in there. But it still runs exactly the same. And as I showed you, it works in Chrome, right? And I'll show you in, let's go to Firefox. Load it up. You'll notice the URL is the same. Everything works. If I go to the developer tools, we'll see here that I'm debugging native modules here. This is not Firefox nightly or anything. I'm not using any special command line flags. This is just the version of Firefox you'll run today. What about Edge? And I'm not talking about, well, what the heck? Let's load the Edge beta. Let's look at that. Modern JS app. Boom. Works in and I expected it to work in the new version of Edge because it's based on Chromium, which Chrome itself is based on. Now, what about Edge? So here I have my modern JavaScript app. It still works exactly the same. If we come in here and look, we'll see in our debugger, for some reason it's not showing. It's weird. It should be showing the import statements and everything. For some reason, they're not showing up. But all of these browsers support that script type equals module. What browser doesn't support script type equals module? Well, at least on my machine, it's Internet Explorer 11. So let's look at IE 11. Here, I have my modern JavaScript app, but that is a lie. This is actually the jQuery app running, because if I go here, you'll see that I have this legacy folder, and in here I just have a copy of my old jQuery app. But in my index.html, I load up script type equals module to my new style code, and then I have this legacy folder, and I'm loading my old school jQuery application. So it works in both. But I bet you're probably thinking there's a problem there, right? I now have to somehow maintain two completely separate applications, one written like it's 2012, one written like it's 2019, right? That's a problem. I don't know about you guys, but I got enough trouble supporting one application, let alone two, especially if they're the exact same UI. And that's a problem that every time I'd give this talk, people would come up to me and say, well, what am I supposed to do? You know, part of the reason I use Babel or TypeScript is to transpile away these things so my code works in old versions or basically in Internet Explorer, and I don't have to maintain multiple code bases. That's crazy. Nobody's going to actually do that. So I decided to look at that problem. And what I came up with, and this is a very, very simple application, consists of a button, and when you click it, it will prompt you, or it'll say something to you, and you click yes or no, or okay or cancel, and it will tell you what you said. So let's look at this application running. And as you can see here, it's just called play. I was playing around with this, got this started, or I got this working today. So I'm going to go to Chrome, and you can see my beautiful application, and if I learn something, I say yes, okay? Now let's look at the actual code for this application. You'll see here I have script type equals module, and it points to source/main.js. If I look at source/main.js, this is an ES 2015 module. I'm importing a function called ask from ask.js, and then I'm actually using that here. And I don't know why there's red squigglies there, but ignore that. And I'm set up an event listener on that button, and when I click it, it will await ask. And let's look at what ask is doing, because ask is a little bit of helper code you might want to consider writing from time to time. Here, I have a blocking synchronous call to the confirm function that's built into the browser. And the problem with the confirm function is that it stops and it waits. But I want to write my other code so that it can keep maybe running or something, so I'm wrapping it in a promise, and my promise resolves whenever that button is clicked, and I return the result of calling confirm. But yeah, it's a very simple application, I'll give you that, but it's an application that this code here won't run in Internet Explorer. So if I want to take this code, it's JavaScript code, if I want to take this code and run it in Internet Explorer, what would I do? How do I take modern JavaScript code and allow it to run in older browsers? Say again? Well, yeah, but I want to take this code. I want to run this code. Really, that's not possible, but we can use Babel to transpile modern code into code that the older browsers will support. Now, I could use Babel and have it transpile everything, and then I could have every browser run that transpiled code. And it'll probably run a little bit slower because there's a lot of code that it has to inject for an await. But I only want that code to run if you're on Internet Explorer, because everything else supports modules and async and await and promises and all of that natively. But Internet Explorer does not support native modules. It doesn't support promises. It doesn't know what a promise is. And it obviously doesn't support async and await. So what I'm going to do is pull in Babel, and I'm just going to configure it to do a couple of things. I'm just using the very basic preset that Babel gives us. It's a default preset. I am telling it to transform my native modules to use AMD modules so that require.js can load them. And then I'm using this module extension plugin that I found that allows me to strip out extensions from module names, which was a lifesaver. So here, if it sees an extension name of JS, it just makes that an empty string. And so instead of saying in main.js, instead of saying import from /ask.js, that'll get transpiled into the require.js for /ask. Now I can run this. I have in my package JSON, I have a build command, Babel. I'm just using the Babel CLI. In the real world, you'll probably build up something a little bit more complex than this, maybe use Webpack or something to do all this, but I am doing the absolute bare minimum necessary to make this all work. So I tell it to transpile the source directory, spit it out to a directory called dist, and I want you to bring on source maps for me. Now, in my index.html file, I do a couple of things. I load Babel's collection of polyfills. This will bring things like promise into the browser so that older browsers know how to work with those things. Then I load require.js. Once that has loaded, I'll load in a config, a very thin little config that I wrote for require.js, and then I tell it to load the main module. And notice that I say main. I don't say dist/main or source/main. I just say main. Now, when Internet Explorer tries to run this, oh, helps if I actually do it. So I will, I'll say npm run build. And riveting television, it'll actually spit it out. Not sure why it's so slow. All right, it spat out those two files. And so if I look in my dist folder, I have a main.js that definitely looks different now. But it's an AMD-style module. Remember I have that async and await? Well, that all gets turned into this generator-style code. Who wants to write this by hand? I know I don't. I'd rather use async and await. Apparently, it has, anyways. So this is what Internet Explorer is going to run. But the cool thing is that I have source maps turned on, so in Internet Explorer, I can still see my import and the actual code that I'm running. So now, if I start up the HTTP server, and I press F5, my little application works the same in Internet Explorer as it did the other way. Now, let me prove to you that this code out of the box, my script type equals module stuff, does not work natively. I'm going to comment it all out, come back over here, and nothing happens when I click the click me button. But because I'm loading in all of this require.js stuff, it does work. And here's the cool thing. I don't have two code bases to maintain. I have one application that gets transpiled for old browsers, and I'm doing minimal or no transpilation for modern browsers. Think about you doing this. Maybe you have separate, maybe you are still using some cutting edge features, or you have JSX that you want to have transpiled all the time, but maybe you have two separate Babel configs or two separate TypeScript configs. I mean, TypeScript, you're always going to have to use some type of transpiler because the browsers don't know how to run TypeScript. But anyways, I'll push this code up to the GitHub repo for this talk and let you have at it. I, again, want to say that I wrote that code in the previous talk, so it's not perfect. So I will accept pull requests if anybody wants to improve it. So that is the modern JavaScript app that I've written. And that also brings this talk to an end. It's been fun. There were some puns in there, so it's been fun. This is the repo I will be pushing the code to. It might not be until Friday that I get that pushed up there, but it will be. If you have questions, you can send, and after the talk, you can tweet at me at Ashley M. Grant. And I blog at aurelia.ninja. I don't blog too often, but when I do, it's amazing, and you should read it. So anyways, thank you very much for coming out. Any questions? All right. Then I have a question for you. Before you walked into this room, raise your hand if you knew that the browser could load native modules. Raise your hand if you knew that the browser, yeah. That's why I love giving this talk, because everybody learns something in here. So now you can go back to work later this week or next week and tell everybody all about how awesome the browsers are natively. And you can start looking at your Babel or your TypeScript config files and consider transpiling less stuff. Especially if you don't have to support Internet Explorer, you should be transpiling very, very little. Let the browsers natively run code. So, thank you.